morning everyone. Welcome to Tejasri Electrical Engineering YouTube channel. In this video, we had discussed about the shape of scale in moving iron instruments. The shape of scale in moving iron instruments is shown in figure. In that we had observed the scale is not uniform. The scale is compressed at its lower end and the scale is not so much compressed at its near the full scale value. The shape of scale in moving iron instruments is well understood by the general torque equation in moving iron instruments. In that, the deflection in moving iron instruments is given by theta equal to half I square dl by d theta by k. K is a constant. Here deflection theta is directly proportional to square of the supplied current, and also it is directly proportional to dl by d theta down here. From above equation, the angular deflection is proportional to square of the operating current and is a square law instrument, and the scale of moving iron instrument is not uniform. If there is no saturation, change in inductance with angular deflection is uniform. That means dl by d theta is constant when there is no saturation. Therefore, dl by d theta is constant. Then the scale of the instrument is square law square. MI instruments exhibit field square law response if dl by d theta, the change in inductance with respect to angular deflection, is constant or uniform, then it exhibits field square law response. But in practically, dl by d theta is not constant and is usually a function of angular position of moving iron vein, and thus the scale is distorted from the square law. Here deflection theta equal to half I square dl by d theta. dl by d theta equal to 2 into deflection by I square. For a linear scale, here I equal to c theta. Here c is a constant. Then put I equal to c theta, 2 theta by c square theta square. Then we have to get theta is take from here. Theta dl by d theta equal to 2 by c square. That means theta into dl by d theta is constant. Therefore, the whole scale of the moving iron instrument is makes as linear scale and a square law device, square law response. For linear scale, the product theta dl by d theta should be constant. By choosing proper dimensions, shape and position of moving iron veins, the product theta dl by d theta is made constant. The variation of dl by d theta versus theta is a rectangular hyperbola shape as shown here. Rectangular hyperbola shape shown here. From the curve given above, the position of scale near zero cannot be expanded or made uniform because dl by d theta cannot made infinite at theta equals to 0. Change in inductance with respect to angular deflection is not infinite at deflection equals to 0. Therefore, the deflecting torque is proportional to square of current multiplied by rate of change of inductance with angle theta. Therefore, the scale is compressed at its lower end because I scale value is smaller compared with full scale value. The scale is not so much compressed at its higher end because the rate of change of inductance with angular deflection dl by d theta decreases slowly. Therefore, the scale is used over about 80 degrees of its length. Moving iron instruments are now available with 240 degrees circular scales. The greatly increased scale length being a certain advantage. The scale of moving an instrument is not uniform and the scale is comped at lower end and therefore accurate readings are not possible at this end.